Polish delay. I, was a bit late coming back from the city center, but anyway. So, this time in the software engineering methods, we will be talking about one of the topics which we were missing earlier, about the boundary, control, and entity modeling, namely BCE model. It's called this. You already have the information on this approach on the course video archive, but technically what it actually does is that it allows us to take the first step from the simplistic domain models towards actually having something that's technical and functional. Today on this lecture we will be using the modeling technique to reverse engineer a small game after I've introduced the model and the basic ideas of it to you. So basically what we will be doing is the first thing we can do to help the developers use the UML designs to get actually something done. And of course, the idea is that we have use cases. We are on our software project in a situation where we have the use cases set, we have the domain model, we have the class diagrams, we know more or less all the actors, and we have the idea of how different things should happen. So we know about the interaction needs, we know about the requirements, we know about the different target audiences, or we can create or get the information about different sorts of interfaces. For example, do we need touch screens or keyboards or anything like that? And we can use this information to make the first design towards actually something functional. So, the idea with the BCE modeling is that we start to allocate responsibilities to different classes. Until this day, we have been using the class diagram more or less as a domain model. It explains how different things are connected. It describes what sort of things are present in the system and what sort of relationships, like associations and aggregations and stuff like that, are in the system. So, all in all, somewhat useful information, but unfortunately it lacks the technical details required, for example, the programmers or system architects to start their work. So, what we are going to do is to evolve these domain models towards more technical or detailed versions of themselves and add responsibilities, activities, and stereotypes, so to say, these classes. So basically, what this means is that we do the BCE analysis. This is a really simple and mechanical way of approaching our work. But if we have no information about the platform or the framework on which we are building our software, this is something that we can start to work with. The name BCE comes from the different analysis class names or stereotypes. The boundary class, which acts as an interface, the control class, which acts as the system that takes care of the flow of events, and the entity class, which more or less represents the stored information or databases. So basically three things: boundary, control, and entity. And by assigning the different things like users or forms or anything really, these sort of activities to the classes of the domain model, we hope to go towards something that defines technical activities. For example, the boundary class, it represents interface. What sort of interface it's up to you to design, but it more or less is something that the actors, even external systems, can interact with your system. For human or people using your software, this may be something like keyboard or mouse or desktop interface or, well, operating system, event handler or touch screen or some sort of other event listener. But in any case, the boundary class represents all the things that are needed to actually get the inputs and send out outputs. The thing that collects information and shows information. Well, of course, besides something like barcode reader or printer or keyboard or desktop monitor, this can also be something like a service port or network adapter or simply a module interface on which other module is connected, but anyway, a boundary class between two different systems. So, how do we draw that? Basically, there's several different alternative presentations. The symbol used here, the circle and this sort of an antenna here, is the one that the rational documentation and the official documentation uses. However, it can also be represented by this or by this, which is the most common way of showing that this is a boundary class, using the stereotype of those sort of hooks around the name. It says that this is a boundary, and it's a boundary between for example here, between the employee and the project management system. The employee sends their information to boundary class, which is some sort of an interface. I'll get back to this in a couple of minutes. So, we have an interface. We can collect information, we can show information. The control class is the one that controls and coordinates the flow of events. So basically, it's the module or component which more or less manages all the other parts. It's the key part, it's the intelligence of the system. It more or less can represent or heavy lifting things like sorting algorithms or functional algorithms or, well, physics engine or whatever, or even a framework on which the application is built upon. But usually it's a sort of a temporary object, because in many programming languages and many platforms, the boundaries and entities can actually do a large amount of work. For example, the boundary class can independently tell us what key the user pressed or what sort of gesture the user did, or the database handling objects are able to do the insertions and retrievals and duplicate detections and all the other things without a separate control class. But the control class, anyway, is involved in managing the flow of events, if such part exists. And the representation for control class is this circle with an arrow in it. Also, similarly, like this is also a control class, and the most common way you will see that something is a control class is this approach. So, basically, the final part of this trifecta of different stereotypes is the entity class. If boundary class is the one that handles all the events and acts as a listener or something that conveys information to user or other external system, and control class is something that manages the flow of events, the entity class more or less models the information and behavior of information management. it means that it's usually associated closely with some things like database handlers or something like that, but it's usually used in a BCE model in any case to show that this is the part or this is the component that stores and manages all the information we are using. So basically, it's something that holds all the information in itself. And the symbol representing the entity class is yet again a circle with this sort of a ground line on it. And the other approaches also work. So, as represented. So basically, what we have is a way of showing that this is related to interface, this is related to internal calculations, and this is related into the management of information. And of course, it's always used to give more technical approach into work. So, then, why are these things useful? Well, for example, drawing something into the whiteboard, if we have interface here, and we have actor connected to that interface, we know that the interface is the one that does all the communication with the actor. So the interface sends information into something that manages all the activities, and this one is connected to other modules which store the information. It's the basic model of thinking how different things work. If we had here other system, I'll just draw you a nice picture of an industry building here. This is also the reason why I didn't get to art school. This is a factory here. If this is another actor, then it also is connected to its own interface. So more or less giving the idea that we have sort of a managed or at least somehow logical way of showing how the system will be constructed. If we consider the boundary class, like on this example here, how it would actually show out means, of course, that if we have a file browser, like on that example there, if we start to think what sort of components actually exist for one file browser in, for example, Windows operating system, it of course explodes into several smaller things, showing all the different components and buttons and bars and drop-down menus and such of the browser window that opens when you select your file. But anyway, the idea is that the boundary class represents the user interface or the services of the operating system, or whatever the event listeners for touch screen or so and so, meaning that it handles all those activities. The control class, like I said earlier, is something that may cease to exist completely. Of course, in games, for example, we need to do physics calculations. We need to possibly do some projectile trajectory calculations if we hit something or not. We have to also probably somehow manage our network connection in case we are communicating with the server. And these are all things that justify the separate control class, something that manages or oversees activities. But if we are doing just some low-level functions like collecting information into database by just using some web form, of course we don't need separate control class or separate control module there. If we are using something like PHP, we can just add the script to the same module that actually creates the form and then just drop stuff into the database and let the database handler or database connection handle all the database actions like making the necessary loggins and insertions and seeing that there's no duplicate information and so on and so on. But basically the idea is that if this part in real life represents things connected to the platform or user interface, this part, which is connected to everything, more or less is divided into different parts or different components, meaning that the activities may actually explode into a huge amount of different things. For example, framework, physics engine, sound engine, network controller, and so on, instead of just existing as a one control class. Well, finally, the entities. Of course, they are actually quite close to the idea of what they are representing in the first step towards being something more than an abstract idea. The entity class, of course, represents the information which is in the system. So the information then is arranged as the database middleware or database model requires, but still the entity classes, for example, employer information, employee information, project information, tables in database, more or less are something that can match the similar project, employee, employer objects or entities in the model. Of course, how they are really actually managed can be something that we have a database handler control class, and then we have just connection to database. But anyway, the entity classes are something that represents the information, and they are used to retrieve, edit, destroy, and add, or in any way manage the information in the system. So, finally, before going to the actual example, I added this slide for you to keep in mind when doing the case work or the case activity. So of course, if we have entity representing the data, boundary representing the interface, control representing the flow of events management or more complex control structures, and actor managing or representing the human aspect, human side, or other system, they can't connect always to each other. So this list gives you an idea how things should connect. Everything besides an actor can connect to control, because the control is the one that keeps the engine going. The actor can only connect to boundary, and boundary can only connect to control and actor. Actor can only use the boundary class here. On several years I've seen things like the actor directly sending something to control classes. I don't know about you, but when I'm playing something like a Fallout New Vegas, I usually don't write chat commands directly into the physics engine. I try to use the user interface. So keep that in mind. The control is the internal mechanics, the boundary is the user interface, and the entity is the data which is managed. On the more traditional way of showing how software architecture is defined, the entities represent the databases. This is also because this model, our approach to BCE analysis, origins from corporate world. So of course, if we are doing corporate tool or corporate service, we need to have someone making the interface, someone ensuring that the data is sanitized and things happen as instructed, and finally we have database to manage all the information flow in and out of the system. So in that sense, this may not work entirely, for example, for games, or it may not seem like a straightforward idea, but keep in mind that these are meant to use as the first step towards making some design which gives the programmers something to do. So, I just said that this may not work in games, so surprisingly we are using this model to reverse engineer a game. This here is this week's assignment. First of all, let's take a short survey. Raise your hand if you know what Flappy Bird game is. Okay, some of you have idea, the rest of you can Google the game in its original form, but let's say that I made a version of the game. So it's a pretty simple game. There's a maze and you try to fly your bird through the maze. It's really simple. If you hit something, you die. It's that simple. You can try this game after I've given you the instructions. So basically what I want you to do is to create the BCE model for something simple as this. It's not necessarily the Flappy Bird game here, and actually definitely not the Flippy Bird game I made, because I'm going to show you how that game shows on the BCE model. But select a simple game or simple software or something and draw the BCE model of that system. I'm going to draw you the BCE model of this Flippy Bird game in a couple of minutes, but read through these questions and consider what components you would have on your software. In your group work, you are tasked then to do the actual BCE analysis model and give a short introduction of your software. The software you are going to do the BCE analysis on or reverse engineering on may actually be something really simple like a tutorial game for JavaScript or some small software used to convert information from one system to another, something like sanitizing database entries for CSV files, as long as it does something sensible. So considering the Flappy Bird example, because I don't have any realistic way of recording the information, I'm going to shut the recording down now and show you the BCE model of the game on the white screen. I'll take the picture of the final model and put it online, but because I can't, really record my drawing while I'm drawing, and it would seem a bit awkward if there's just some random noises on the recorder, I'm going to stop the recording now and go to the whiteboard. If you don't see from the back row, you might want to come a bit closer here to see the presentation on the whiteboard, but unfortunately I can't put that online.